Hey gang, how you doing? Matt here. Today, or this video, this portion of the video at least, will talk about ConOps, concept of operations. This should be a review. We talked about ConOps, concept of operations, last week when we saw you live. So this is going to be a review. I'm going to assume that you know some things already in this video. And furthermore, follow along. Concept of operations, ConOps, starts on page 42 in your notebook. So please follow along. It's very valuable information in here. And I'm going to use the notebook as a sort of a guide as we talk about this. But I wanted to review some things, and I want to introduce some new things and give you all an example of some ConOps before we move on. And I know you can't see this presentation behind me. I apologize for that. But just this presentation is online on the downloads page. It's called ConOps, Concept of Operations. You can download it and follow along. It'll be in PowerPoint for you. So anyway, ConOps, this video is going to be very short, hopefully. And so I'm just going to go through and I'm going to define concept of operations again for you, and then define what the phases of a mission are. Then I'm going to go over an example of ConOps, and then I'm going to wrap it up, basically. So first things first, what is ConOps? It's in your book on page 43. It's also on this next slide. ConOps is a description of how the system will be operated during the mission phases in order to meet stakeholder expectations. So what does that mean? Basically, it's what happens during the mission. What does your payload do? What does it do? What is experience? What goes on during the mission? And to meet stakeholder expectations, that means basically to accomplish your mission. The stakeholder in your case is NASA and UAH. NASA wants you to accomplish some science, and UAH wants you to accomplish some science without hurting them and without costing them too much mass and power and stuff. So, so basically, can you accomplish your science? The ConOps, the concept of operations, are how you are going to accomplish your science. What happens to the payload, what it experiences, what it does, blah, 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 blah. What goes on, essentially, to accomplish the mission. It's important to explain that. I mean, obviously, you've got, like, so far we've talked about alternatives, we've talked about instruments and whatnot, but what actually happens is very important, because that's a sticking point for a lot of missions. Is that really going to work? Can that happen that way? So that's why it's important. We mentioned also mission phases in this definition. A phase of a mission it's basically a period of time, and it's a period of time over which, as far as the payload is concerned, things don't change that much. Now, things could be chaotic, but that's still a phase, the chaos phase. You can call it that if you want. But it can be like your payload can be moving around chaotically, or your payload could be accelerating toward the planet at a very high rate. But that's still a single phase, because it's just accelerating during that phase. Not much else is going on. When it hits something, if it impacts something, that's a different phase. You've entered a new phase because it's changed a lot. Or when you're deploying from the vehicle, that's the deployment phase. But once you leave the vehicle, you're no longer deploying from the vehicle, so things have changed. So it's a new phase. So you want to break up your ConOps, what happens to your payload, into phases of time, so that you can explain it to people. But you don't want to have too many phases, or it gets ridiculous. Just a handful of phases, 3, 4, 5, something like that, should be adequate. And but phases help you break down the timeline of your payload so that you can explain it to people. Now, the ConOps checklist, we talked about it last week when we were live. Hopefully we did. If we didn't, I apologize. But it's all online. It's on the downloads page under the checklists box. ConOps checklist. This will be your best friend for ConOps. Use this. I can't emphasize this enough. It's a beautiful document. PJ and I spent hours and hours and hours on this. It's in Word format, so you can download it and you can type right into it, and you can alter it. You can answer the questions. Basically, this thing just asks you questions. It goes through and asks you a bunch of questions, and that's why it's in Word format, so you can answer the questions. Some of the questions will apply to you. Some of them might not. We had to write as many questions as we could think of, and not all the questions will apply to every payload. But the ones that apply to you, answer them as best you can right now, at least. As much as you know right now, you can estimate, and you can say, if you're supposed to put a number in there, just put blah or put XYZ or whatever for a number. But it's something you need to figure out later, that number is, obviously. But just know that those questions apply to you. Those are things you're going to have to figure out later. But use the ConOps checklist. It's divided. It's also divided into main phases. The initial conditions phase, basically what happens, what is your payload like before anything happens, before it starts to deploy, what is going on outside, what is going on with the spacecraft, are you in orbit, are you on a balloon, are you on a lander? Right before you start to deploy, what is going on and where are you? That's initial conditions. Deployment, that's, as the name would suggest, it's as you're deploying. You know, how you're deploying. Are you being pushed out by helium? Are you being spring? Is there a monkey that's pushing you out, or is there a ferret? You know, a dung beetle would be interesting, but not very effective. Anyway, measurement-wise, what measurements are you taking and how are you taking them? What's going on with the payload? Lots of questions in there about measurements. Sending the data. This could happen simultaneously with the measurements. I don't know. It depends on what your plan is. But sending data is important. It's probably the most important thing. If you when I'm at home, if I empty the dishwasher and my wife doesn't see it, does it count? No, it doesn't count. If your payload collects the most awesome data ever, you discover life on Venus, but you don't send that data back to Earth, did it happen? No, no one cares because no one knows about it because you didn't send the data back. So sending the data back is extremely important. Can't emphasize that enough. The last one is other. You know, if you're going to impact the surface, other. There's some just a catch-all basically for the last few questions. But go through these questions. I can't go through it. Ask us questions about these questions if you like. And but I can't. This will be your best friend. Please use this. It's on the downloads page under checklists called the ConOps checklist. That should be a review, hopefully. So now I'm going to go through an example of ConOps, okay? And I know you can't see this that well with the screen, but look at it on the PowerPoint that you have downloaded, and we'll go through this. Let me look at the book real quick. So the main thing about ConOps and what this example hopes to teach you is that engineers are very visual creatures. We like pictures. I like pictures. PJ likes pictures. We like when you open up a, you know, like I'm a geek, right? I'm sure this is news to everyone. And I like to read computer magazines. I'm sure this is, you're like, shocker. But so what do I do when I read a computer magazine? PJ's making comments. I'll probably hear him. What do I do when I read a computer magazine? I open it up and start looking at the pictures and start reading the captions because I don't
all about Dell's.
Yeah, no, I don't. It's actually Apple magazines. Yes.
Shocker.
I know. So okay, enough from the peanut gallery. They can't even see you. So so look at the pictures first, and the pictures are interesting. They draw your attention, right? And I'll read the captions, and if those look interesting, then I'll read the article about that. You know, whatever. So pictures and little icons, things that help give information in an interesting way. Words, not that interesting. So I'm going to go over some examples of ConOps real quick and just to hopefully show you that. So here we have, PJ and I worked on a mission several years ago where we were going to put probes on the moon, on our moon, Earth's moon. And we were going to put probes on the moon to collect temperature data. And we had two concepts for two different types of temperature data. The first one was a penetrator concept where we're going to, the penetrator was going to be released from, there's an orbiter flying overhead over the moon, going around the moon at around 50-kilometer orbit. It was going to be released from this orbiter. This penetrator was going to fall toward the surface, hit the surface, bury itself, and then take measurements from there. Take temperature measurements, heat flow measurements actually, along the length of the penetrator. And then concept number two is called the surface probe. It was taking temperature measurements, but on the surface alone. So we were going to drop spherical probes. They were also going to be released from this orbiter flying overhead. It's going to release these spherical probes. They're going to fall, accelerate with gravity toward the surface of the moon, hit the moon, but they were not going to bury themselves. They were going to skip across the surface and then come to rest after a certain distance. Then they were going to measure surface temperatures on the moon. Okay, so those were two ConOps. Those were two concepts that we came up with for a mission way back when. Very kind of high level, like just telling you what's going to happen with our mission. So that was a ConOps. That was the explanation of ConOps. Was that interesting? Was that fun? Was that? Are you asleep? Hello, wake up. So was that good at all? In my opinion, no, it was not. Better explanation of ConOps would be this. I hope you can see this. It's on the video. So, concept number 1 is a lunar penetrator. There's an orbiter flying overhead, 50 kilometers above the surface of the moon. The orbiter releases a penetrator. The penetrator looks like a torpedo, basically. It's a long, or a missile, if you will. It falls toward the surface of the moon. It hits the surface, impacts the surface, and then buries itself a certain depth under the lunar surface. We don't know how deep right now. Haven't done that, but this is just the idea of how it would work. This penetrator is a certain length. We don't know exactly how long, probably a meter, and it's going to bury itself under the lunar surface. And then from that point, it's going to take heat flow measurements, which I'll explain in just a second also. The second concept is the surface probe concept, where we have an orbiter flying overhead, 50-kilometer orbit again. It releases spherical probes, several of these actually, that would hit the surface and would bounce, skip, kind of just glide, skip, that kind of deal along the surface. It would make that noise actually, and it would come to rest after a certain distance on the surface, and then it would take surface temperature measurements of the moon. It wouldn't actually take heat flow measurements. So that's the concept too. Now the heat flow measurements, just to give you just to let you know how the heat flow works, is the penetrator, or our penetrator, which is straight down in this picture. It's a certain length, say about a meter, is so far our initial estimates of the length of the penetrator. It's going to have temperature thermocouples spaced out at different intervals, every few centimeters. Those thermocouples are going to measure temperature. Those thermocouples are going to be fixed distances apart, and they'll measure temperature. And we'll have temperature measurements from the surface of the moon all the way down to the end of the penetrator, the tip of the penetrator, where the last probe is. So that's how heat flow works. And if there's differences in temperature, then that can be inferred as heat flow. So that was the second way to explain ConOps. That was a pictorial way, using pictures, using cheesy PowerPoint art. Okay, I literally drew this with a mouse, and this is actually the same, this is the same exact terrain. Use the same terrain twice, you can do that. And then I drew some cheesy drawings, and boom, this took like maybe 10 minutes in PowerPoint, okay? The second one, and I put a gradient on this to make it look cool, right? The second one, the second picture, same thing, same lunar landscape actually, and put a different gradient so that it looks like it's hot down there, right? Because you want to show the heat, right? And so, but it explains the mission, it explains the two concepts in a much better way, much more interesting, I think, to show pictures and to talk through the pictures than it is to show text. Boom, 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 boom. Boring. Everyone's asleep. No one's awake anymore. So when you're explaining your ideas to the board, pictures help, because engineers like pictures. They want to see a picture. They want to hear you talk through the picture. Okay. That's concept of operations. That's what we want you to do. We want you guys to have pictures. If you can draw PowerPoint stuff, awesome. If you have CAD, sweet. If you draw on a whiteboard or on a piece of paper and scan it or take a picture of it and put it in there, that's fine. That's fine for this status review, because we've only been doing this for about a month and a half or month. So that's fine for now, but you want to make it, eventually you want to have digital, some computer drawn things, even if it's cheesy PowerPoint, you want to have these in the end. Or if you're artistic, you can draw nice pictures and put them in there. A lot of teams for their pictures, they do like a storyboard type thing for the different phases. They use their phases as different images and show their payload in different phases. It's like a storyboard. If y'all have ever seen a storyboard like for a movie or something, you know what I'm talking about. So pictures. I can't emphasize this enough. Pictures sell. Pictures will help explain your concept to someone that has trouble understanding your concept. So, because remember, you're going to Venus. Not everyone's familiar with the planet like we are, and so you're going to have to explain what's going on about the planet, what you're doing on the planet, so on and so forth. And the pictures will help show a lot. Basically, it helps explain everything a lot better. Okay, so the wrapping up for this video, ConOps. Use the ConOps checklist. I can't emphasize this enough. This is out there for you in a docx format. If you need it in a different format, just let me know, and we'll send it to you in a different format. I don't know what format you'd want it in, but we'll send it to you in a text file or semaphore, whatever you want. Morse code. So use the ConOps checklist, answer the questions as best as you can, and then use those answers to those questions to help explain what your payload's doing, what's going on, what your payload is experiencing. Divide your mission into phases as best as you can right now, based on your ideas. What's your pre-deployment phase, your initial conditions? What's your deployment look like? What does your measurement phase look like? What does your sending data phase look like? And then what does your death, I guess, look like? How do you end the mission, your end of mission? How does that work? Explain what happens at the beginning of the phase or right before the phase, during the phase, and at the end of the phase into the next phase. That's how you explain a phase. Pictures, pictures, pictures. 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 Pictures sell. That's my Clinton. Pictures. Hello people. Pictures. Do y'all know who Clinton is? Do they know? I don't know. Do they know who Clinton is? Probably not. Anyway, teachers like that joke. Okay. Teachers love my jokes. So, practice explaining. This is important. This last bullet, I don't want to get too goofy just yet. Practice your ConOps. Explain, use your charts, whatever you're going to use to explain during your presentation. Explain it to someone not in the class, your parents, another teacher, your friends, whatever. Explain it to them and see if they understand it. If they go like this, if they're like, if they don't understand what's going on, then you need to do a better job of explaining it, okay? If they go, I get it, I understand what you're doing. Good job then, you've explained your ConOps well. Teams, we've seen the teams with incredible designs and with incredible ideas, they just can't explain them well. So we want you to do a good job of explaining your stuff. And so practice on someone who doesn't know what's going on. That's the best way to practice it. And last thing, pictures. Pictures. Put pictures. ConOps are made for pictures. A ConOps without pictures is dead to me. So anyway, if you have any questions, email us. Talk to us when we see. Dead to me. That one?
No, what's important?
Pictures.
Sure.
Pictures.
Yeah.
So, okay, all right, that's about it. Thanks, and we'll see y'all soon. Bye-bye.
Hey guys, I'm going to talk to you about the payload status review and everything to get ready for that. Matt gave you that wonderful lecture about ConOps that I know you're all just thrilled with, and I don't believe Matt wanted you to put a picture in at all.
Pictures?
So don't ever think about those pictures as the thing. So you need to remember during the review, there's two things you've got to do. You've got the payload status document, which is the 5 pages, which includes the title page. So really it's 4 pages of meat that you need to fill out, complete, and submit to us. You need to submit that a week before the payload status review. So probably when you're watching this video, you should be in the final stages of submitting that to us. And you submit it through the Inspire's website on the uploads page, right, Matt?
Yes.
So, and to go along with that, you've got the template online, but we also are going to we'll have a document out there for you that will explain sort of what's in each of these sections in the template. And so hopefully that'll help you out a little bit there. The other part's the payload status review, where you have the presentation that you give to UAH. The UAH students and faculty will be a part of this one. So you get up to 10 minutes to talk to them, and they're in different rooms, and I think Matt's going to show you both of those rooms so you can see what it's like on this side of the camera, or this side of the screen. And so we'll show you those in a minute, but I wanted to go over those, the template that's out there, the PowerPoint template, to make sure you understand everything that's required for that. There's also on the downloads page a thing where the template's there, and there's some instructions. There's going to be an instructions part of it as well. So hopefully it will help you as well as this video, okay? So the first page, obviously, is the title page. On the title page, you need to remember there are little brackets around things. Take those out. Put in where it says team name here, high school name here, put your team name. Put your high school there, right?
Also get rid of the brackets.
Team logo here. Yeah, get rid of the brackets. Take all that out and put your crap on there, okay? This is a big deal. Don't leave that at all, because if you do, you look stupid, and we don't want that, right? So make sure and do that one. So that's title page. Number 2, agenda, right? And if you notice on the agenda on slide 2, in the left-hand corner it says team logo here. On the right-hand corner it says school logo here. Take that out too and put those there. That is on every slide in the template. We want you to eliminate those and put your team logo and your school name there. If you do not have a team logo, which you should, but if you don't have a digitized version of your team logo yet, take out that stupid name anyway. Get rid of it. Just leave it blank. Because if you leave that there, that just looks really stupid. And it actually shows the board that you are lazy and you haven't done what you needed to do. So do that. Get rid of it. Okay? The agenda slide, it's already pre-made for you. Don't modify it. You can add to it if you want to, but do not subtract. We have seen this happen in the past where people have decided, well, we didn't do one of these things, so we'll just eliminate it. No, we know that, okay? Because we created the template. And we actually have a review sheet that has each of these things on it. And when it's not there, it's just a big fat 0. It's not scored from our perspective. So don't do that. We can figure it out. Now, if you want to add some slides to it, you've got some more information you want to put in there, great. You can put that in the agenda. But basically leave this one alone unless there's like some major thing. And if you need to ask, send a message to one of us or ask your teacher or something like that. But really, this slide's kind of self-explanatory. It's a good deal, okay? So leave it alone. Slide 3 talks about your team, okay? You've got to walk them through this process, okay? You've done this now for a month and a half, and so you got your team, your PM, your chief engineer, all these guys, right? But we don't. So the dudes at UAH don't, okay? Nobody, nada. They don't know you at all. So tell them about who they are on the team. So-so is the PM, so-so is the chief engineer, so-so is in charge of cake decorating. I don't care, whatever it is. Put it all in there, right? You also need to include that UAH point of contact, okay? Matt will give you this person in theory sometime, and so you should say, and our UAH point of contact is blah, right? So during this part of the presentation, you will tell each of these people. This is a good way for everybody to go, hi, that's me, and introduce yourself so you see each other, right? And then also remember to say, and blah, 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 John Doe, Jane Doe, I don't care, is the UAH point of contact. You would be surprised at how often that point of contact is sitting in the room on the judging side, on the evaluation side, over here at UAH. And if you don't say their name, they're going to be really ticked at you, okay? So just say it. Say, blah, blah, blah is the point of contact, That's all you got to say. End of story. Bye, right?
Please write the team members, your team members' first and last names on this slide, because I use this slide for rosters of teams.
Yes. Okay, so first and last name for the team. Okay,
just bullets or whatever. Yeah.
Yeah, just bullets. We don't need paragraphs. And remember that. Do not create sentences in this presentation at all. Okay, I don't want to see a freaking period at all. Okay, that's a big deal for me, because if you do, you're going to sit there and instead of like I'm doing right now and talking to a camera, which is weird, but I'm talking to a camera. I would instead be going, "Hello, my name is PJ Benfeld. I am from UAH." See, I'm reading. Are you stupid? You can read, right? So don't do it. Don't put sentences, because that will do it. And that will drive me crazy if you do, and I will mark out on that too. Okay. Maybe this marks. There. Slide 4, team identity, right? So now we want to know about the name, we want the logo, we want the slogan, we want the whole concept here. And just don't, I've seen it so much already, don't put the logo and go, this is our logo, this is our slogan, next. What does that mean? Your logo and your slogan probably have something to do with either your team or your payload or some combination of that. Explain that to them, okay? You put a lot of thought in this. I know, I have seen all of you already. You've each put a lot of thought into why you are what you are. Tell us why you did that. That's a little cool thing about you. And the board goes, that's neat, right? If you do boring doesn't help. Boring only makes us really get pissed. So don't do that, okay? Slide 5, quit the laughing. So slide 5, this is the Matt's in the little corner here laughing off the screen if you can't hear that. Slide 5 is the community engagement activity plan, okay? So what we want here is, what are you planning to do? What plans have you already made, okay? That's all we're after here. We don't expect you to have done anything, but the CEA group better have started figuring out stuff by now, because you only got a little bit left to do it. And you will not believe, you might think, oh, talking to elementary kids ain't no big deal. Coordinating it, getting everything ready, getting all those kids, everything. There's a lot of work that goes into this. So by now we want to know what's your plan, right? So what's your plan for the CEA, right? And you can have several CEAs. Tell us about each of them. What's the activity? Where's it going to be located? How are you going to publicize it? What are you going to talk about, right? What do you have to accomplish in doing it? Each of you have really neat science objectives now. We're seeing them. And so you've got really neat CEAs. You've got a billion different CEAs you could do. So tell us what your plan is, And this isn't like locked in stone. You don't have to go, well, crap, we put it on that slide, we got to do it. No, and you can add things to it, right? You can add different CEAs because your goal is the 250 people, right? All that stuff from the competition rules. So you can add, subtract, whatever. It's just, what are your initial thoughts so we understand, right? And Matt's going to interject here because he's got his finger up.
Make sure
I don't know why,
they
because it's only us in the room.
Make sure they delete those questions that are on the slide currently.
Oh yes, eliminate all text that's on the slide currently, okay? That also makes you look stupid if you don't do that, okay? I don't want stupid. We ain't gonna do no stupid, okay?
So you should just start off not by saying what is the plan, just start
Say
off by
blah, 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 tell us the CEA, right? Just don't put that in there. Number 6, what we want on this one, UH mission background, is we want you to be able to tell us what the UH mission is, okay? Because you need to understand what UH is doing before you can decide to propose a payload to us, right? So we want to understand that. So what are we doing? We're going to Venus. We're doing blah, and blah, right? You know all this blah, right? You're going to put the blah in there. Which spacecraft are you going to be on? What is your plan so far? Are you on the orbiter, the lander, the balloon? Are you on 2 of the 3? Whatever. Tell us what that is, right? And where are they going, right? The orbiter goes in orbit. It does, 230 kilometers, 230. Lander, going to land on the surface at the equator-ish. Yeah, okay. And the balloon does some things at 55 kilometers, right? So all that. Put that in there, because then the dudes at the UAH can go, cool, they understand what we are doing, and they are doing that correctly. If you say it wrong, at this point, they're going to go, time out, we're not doing that. So you need to think about that before you continue with your payload design, okay? So it serves 2 purposes. First of all, you can tell your customer, which is UAH, yes, I understand what you're doing, and B, then UAH can say, wait a minute, you might have had a little bit off there, make sure your payload's doing exactly what it needs to do. See, it works both ways.
There's a few slides already in PowerPoint format on the downloads page on the in the science presentation and the introduction presentation that go over the UH mission. If you want to just use those.
Notice I didn't interject in Matt's ConOps video, but he just feels like he has to just comment in mine. I don't know why. It's kind of like an irritating thing for me, and I'm going to kill him in a minute. So you might not see Matt once you see this video. So FYI.
This is evidence.
No, it isn't. Number 7, payload design requirements, right? This is where we want you to tell us we understand our requirements, okay? That's what this little section's about, is we understand the mission, we understand the requirements, and this is our payload because of that, okay? So, under this one, we want you to put the project requirements. These are the simple things, right? We went over a video about requirements, like the 5 kilograms, volume, don't hurt us, autonomy, that kind of crap, right? That's the kind of things that are project requirements. Functional requirements is the one that Matt gave you that riveting lecture on going to school. That is not sarcasm. This is sarcasm. You don't need to agree. Sarcasm, right? So, but functional requirements, deploy, house, that kind of crap, right? There's 6 of them. Make sure and tell us, and that's all you got to put is our functional requirements are, you put functional requirements, dot, deploy, blah, and put we have to deploy, we have to measure. That's all we want. Is that you regurgitate this stuff to us because you're telling UAH, the UAH students and faculty, we understand what you want us to do, okay? That's all this is. It's not rocket science. It's really simple, okay? So do that one. Number 8, sorry. Number 8, payload destination. Where are you going? Where is your payload going? Because you might be on a balloon, but you're going to drop from a balloon, and so you're going to the ground, right? Well, your destination is ground, not balloon. So you need to tell us where you're going, right? And then what's the environment like there? Look at that. There's that environment requirement. Ooh, there we go. There was one of the other ones, right, that we talked about in requirements. So environment like there, well, how hot is it? How cold is it? What's the pressure like? Is it raining sulfuric acid? All that kind of stuff. Because we need to make sure you understand, I got it. I know where I'm going, and I know what it's like there, right? Because that's how you got to design a payload. If you go, I don't know, it's hot. What? We need temperatures, 900 degrees F, whatever, billion degrees F, whatever it is. Please put that in there, okay? So that's on this slide. Number 9, science objective. This is the dude we've been talking about for a long time with you now, right? So tell us what the science objective is for your payload. You're measuring this, you're doing this, whatever it is, right? And then we also want you to put why, so what. Why is that important for us to do, okay? Because this is the practice. Remember, these are the practice runs to get ready for NASA. When you come to see NASA in May at UAH, that's very important to them, yes? They want to know, well, why do I care about doing whatever on Venus, So you need to make sure you have that down there as well. So what's the importance about this, right? That's kind of cool stuff. On slide 10 is the science traceability matrix. Take the table that is on page 24 of your book and put it here, okay? You can put it here and then talk to us about it during the presentation. Go, our science objective is blah, 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 which then it makes the measurement requirement blah, 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 which makes this, which causes this instrument. Just tell us just cell by cell, in the table what you're doing. It's totally simple, right? This can work. Likewise, the next one is the instrument table. So take page 25 in the book, plop, right here, right? So then you can say, given those instruments that we just talked about, these are the resources that they require. Ta-da! And you're done. Because then you've satisfied science requirements, right? So then we got all 4. We got project, functional, environmental, and science. They're all done. So now you know exactly what requirements you need to design your payload. See? This is simple, right? That's what I thought. See, you have to agree with me because there's not better in here. The next slide, alternative solutions methodology, right? So we came to you and we talked about alternative solutions. And what we did was said, split into 2 groups. One could be headed by the PM, one could be headed by chief engineer, or whatever you did, right? Put that there. Tell us how you did that. How did you come up with the different alternatives, right? And what I really like here is a flow chart, where we were all together, then we split up into 2 groups, group A, group B, whatever. Then group A came up with this, group B came up with this. We came together, we thought about it a little while, and this is what we did, Nice little flow chart. Engineers love flow charts. We just love that crap. So you can put it in words, but that's boring. Pull it in bullet form. But just put up some flow charts. Just flow it. It's the proper, okay? I'm figuring out what I'm saying here. Shut up.
Just flow it.
Yeah, just flow it. Number 13. This is where now you talk about each concept, right? So we're going to talk about each concept, right? We're going to go requirements. Then we're going to say, this is how we came up with the concepts. And here's the concepts. Look how this flows. It's real pretty. So first one, concept 1. Describe it. Tell us what it looks like in bullet form, not paragraphs, not this payload shall be blah, 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 blah. No, right? Put us a figure. If it's a hand sketch that you had to take a picture of, put on a wall, on a board, and you just do whatever. Give us a picture. We need to see what it looks like. And then tell us, how does it deploy? How does it measure? How does it collect data? How does it provide power? How does it send data? And how does it house or contain the payload? All the functions. Tell us how it does all of those things. That's answering the mail, right? That's doing it. Okay? So do that one. Concept 1, ConOps, number 14, is the stuff that Matt just talked about with you. I know you probably fell asleep, so rewind and check it again. But then, tell us what it does. So when we say go, when UAH says, now, see, I woke you up there, didn't I? That's the point, right? And it's on some pages. Oh, ConOps checklist. Always want me to point out. ConOps checklist, which he and I did, and he had to really take credit for it, but that's all right. All that stuff. Put all that in here, and draw it. Remember, pictures. Although I don't think Matt really wants you to do a picture, but pictures, right? So put a picture here and then just describe it to us. That's the cool stuff, When you have a picture here and you're just talking about the picture throughout, because that means you really know what you're doing, right? So do that. Number 15, exactly the same thing. You've got 2 concepts. Do it again. Do it for the concept 2. Give us a description. Put the figure. It can be hand sketched right now. That's okay. And then give us the solution. Give us the how of the different functions, right? And then again, there's another ConOps one on slide 16. So that one too, right? Tell us how that one goes to works once we say go. You know, so it deploys doing this, it does this, it does that, it does that, right? All that goes on this ConOps slide. This is cool stuff. So, to round us off. Okay, so after that, what we want on slide 17 is we want you guys, we haven't done decision analysis yet, and that's okay. But what we want you to do is look at those two concepts. You got concept 1, concept 2, right? And then we want you to sit there and go, huh, well this one, its pros or its positives are blah and blah and blah. But its shortcomings, its downfall is blah and blah and blah. But number 2 has good things of this and this and this, but its bad things are this and this and this, right? List that here, you know, and you can even do a chart, a table where you put concept 1, concept 2, pros, cons, right? And just list them, okay? We want to know, the point of this chart is that UAH knows you realize that there are some things that are good and some things that are bad about everything. Everything has this in life. Every payload does, right? And so there are some positives, but there's also some negatives. And so we need to work on that. But that's what they are, because we need to realize that you are thinking about this, you know? It's just like Matt. Matt might be a great guy, but there's some things he really stinks at, you know? One of them is speaking, which you already got. But, you know, there's some things that he's really good at. Likewise with me. I don't have as many negatives, but, you know, there's some. So, and see, he's laughing, like he's, really, you know? So, that's the kind of thing we want on this chart, okay? Because we realize there are problems with your payloads. That's cool. Because your negatives, when we start looking at them, UAH, the people around the table might go, well, you know how you could solve that was be doing blah, blah, blah. This is the time to talk about it, right? And so, last but not least, we need to know what you're going to do next, right? You're hopefully going to make a design. You're going to do some decision analysis. You're even going to do some stuff on CEA, because you're going to conduct the CEA, hopefully, by the time we see you next time. You see them next time. And then, what's the physics stuff we're up to? You know, there's this concept called physics. It's a weird thing, you know? And so we want to know, what are you thinking in the physics world? How are you going to analyze this thing? Because that's a big deal. And that's what Matt's going to be like with you over. It's just his thing, and pity you people now. But that's your thing you're going to have to do with him. So give us that kind of stuff. Give us some indication you understand which direction you're going to go. Okay? That's what we're after there. And so the last thought is restate really quickly what you've done throughout this whole presentation. Tell us what you've done so far. We created a team, right? Our team name is blah. We have a science objective that is blah. We've created 2 concepts, concept 1, concept 2, give us a little bit about it, and say, thank you very much. Bye. You know, that's what we need. Now realize, 19 slides, whoo, 10 minutes. They got a long time to talk, you know. I would be really bad at this because I could talk about every slide for like 25 minutes. So you got to remember, you got to be brief, to the point, get out, right? That's the kind of thing we do with this. So hopefully this helps you understand more about what we want in this presentation. We'll also have, like I said before, the instructions that'll help you as well and kind of in form as well. But we wanted to make sure and give you that as a preview. So I think what we're going to do is kind of show you the rooms where you're going to be at and that kind of thing, so you understand kind of what this side looks like when you're doing this. So talk to you soon. Again, remember, anytime you have a question, feel free to email us and we'll get back with you as soon as possible. See y'all later. Bye.
Hey gang, like PJ just told you, we are going to show you now the setup, the arrangement that is going to be on the UAH side when you present via Skype or Polycom for the payload status review. Right now I'm doing a video selfie, which is kind of weird for me. I feel like Ty from Extreme Home Makeover. I don't know, is that show still on? Anyway, so I'm going to whip the camera around here and show you guys. So this is the setup that you've seen us present in front of a few times, but this is basically the same setup that we use when we have the presentation. This screen, the screen that's taller, the screen that's actually on right now that has the camera at the top, that webcam at the top, that's the screen that's going to have Skype on it. And so that screen will show your nice smiley faces and to the UH people, and then this screen right here will have your PowerPoint running. And all that also, so just as a note, you need to turn in your PowerPoint at least 2 days before your presentation so that we can print it out, so that we can have it on this computer. The board, on the UH side, they're going to sit at this conference table. This is basically what the room looks like. There's PJ. Hi, PJ. So here's the 2 TVs. There's the 2 plasma screens, and there's just a conference table right here. So they're going to sit right here and face the televisions. In front of each of them, they're going to have a copy of your presentation. And we're going to have a microphone in the middle of the table there so they can talk to you guys, so they can hear you. But so they're going to have hard copies, printed copies of your presentations in front of them. And then they're going to watch you via Skype from the televisions at the end of the room. And then your presentation will be on the shorter plasma as well. The PowerPoint will be on that plasma as well. So that's what's going to be. This is the setup for Skype. If y'all are going to use Skype, some teams will use Skype. Some classes will use Skype. Some will use a Polycom system, or maybe your Access Lab that you have at school. And that's a different setup we'll show you in just a second. But anyway, so just wanted to show you guys what it's going to be like on this side. So they're going to be at a conference table, and they'll see you. So it's important that, the reason I'm showing you this, it's important that you talk clearly and that you turn in your PowerPoint ahead of time so they have a hard copy of it on the table for them. All right, well, we're going to show you the Polycom room in just a second. Okay, thanks. Hey, gang. Again, self-video here. Sorry. So we are in the Polycom room. This room, if for your payload status review, or your payload concept review for that matter, if your teacher wants to do it via Polycom or via your Access Lab, this is the room that we'll use on the UAH side. So there's one screen in this room. On this screen we will see your bright and smiley faces. Then opposite the screen is the UAH people. That's where the UAH people sit. And you see the large microphone in the center of the room. So it's just a big room with concrete walls. It's a former classroom is what it is. And so you can see, here's the other end of the room from there. You can see the camera is directly below the screen in this room. So as the UAH people, as they look at you, when they are looking at the camera, they're actually seeing you at the same time. So much, very similar to the Skype setup we had at the other location. So anyway, this is what the Polycom room looks like. There's just a bunch of chairs, a bunch of desks, really concrete walls, kind of drab looking, isn't it? But this is what it looks like here. So this room, again, it's important for everyone to submit their paper copies to submit the PowerPoint presentation 2 days prior to the actual payload status review. But in this room especially, because there is no TV that shows your presentation. The board will see only your smiley faces on this screen, and then they will have paper copies in front of them of your presentation. So as you talk through it, they will follow with the paper copy. So that's very important for you to turn in your presentation. For both, really, for the Skype and for the Polycom, it's important because what the reviewers do is they let's get a picture of PJ real quick. What the reviewers do is they write notes on the presentation, because with this payload status review you get 10 minutes uninterrupted. They can't ask you a question for 10 minutes. So the paper copy is important for them so that they can write notes down, write questions down while you're presenting, and so they can see your PowerPoint clearly as well. It's best to see it printed out in front of them so they can write down on it and see it more clearly. Anyway, that's it for now. If you have any questions, send me an email, send PJ an email, whatever. Ask your teachers to email us. This is the Polycom room, and you just saw the Skype room, so you know what it looks like now. No excuses. We expect great things from y'all. Okay, thanks. Talk to you later. Bye-bye.